Hello everyone, I'm going to be going over homework number 9, it's number 18. At a certain university, 16% of students fail general chemistry on their first attempt. Professor Brown teaches at this university and believes that the rate of first-time failure in his general chemistry classes is 33%. His sample 96 students from last semester who were first-time enrollers in general chemistry and finds that 15 of them failed this course. So something to take note of is that we're dealing with 3 separate questions for number 18's whole information. So let's start with number 1, 18.1. State the appropriate null and alternative hypotheses. So let's go over to the whiteboard. So what 18.1 is saying, state the null hypotheses H0 and the alternative hypotheses H1. Now, how do we know which one's which? We have 2 percentages. Well, Professor Brown teaches at this university and believes that the rate of first-time failures in his general chemistry classes is 33%. This is a certainty. This is what he knows. So we're going to be using that 33%. We're going to use the 33% and change it to a 0.33. So it's going to look something like here. H0 colon P is certainly equals to 0.33. And since he doesn't state that if it's less or greater, we are assuming that it is H1, the alternative hypothesis, colon P is not equal to 0.33. And with that, we got 18.1 done. Next up, number 18.2. Compute the test statistic Z. So let's go over to the whiteboard. 18 number 2 says find Z, and how we're going to find Z is using this formula. P hat minus P divided by the square root of P times Q divided by N. So let's write down what we know. We know that N is equal to 96, X is equal to 15, our null and alternative hypotheses, P is equal to 0.33, and P is not equal to 0.33. And one more piece is, as shown here, 16% of students fail general chemistry on their first attempt. So that is going to be our P hat. We're going to change the 16% into a 0.16. So that is our P hat. The only thing we're missing is Q. So let's find that. So to find Q, it's just Q equals 1 minus P. And notice how I said P and not P hat. The P is our null hypothesis. P equals 0.33. So we're going to plug in this P, or 0.33 for P, and we're going to get 1 minus 0.33. And with that done, we get Q equals 0.67. And with that, let's move on to finding Z. So like I said before, we're going to be using this formula. And we have everything we know, and P, null hypotheses, and what we just did right now, Q. So when everything is put together, it's going to look something like this. 0.16 minus 0.33 divided by the square root of 0.33 times 0.67 divided by 96. So I'm going to do this top part and this middle part, and it's going to look something like this. Negative 0.17 divided by the square root of 0.2111 divided by 96. And with this whole thing done, it's going to equal to negative 3.625270 with some more numbers behind it represented by dots. And we're just going to, what is it called? Sorry, lost my footing there. We're going to round it. So that's going to be Z is equal to negative 3.63. And with that, we have done 18.2. Last but certainly not the least, 18.3. Using alpha equals 0.05 can include that the percentage of failure differs from 33%. So let's go to the whiteboard. So what 18.3 is asking is, do we reject or don't reject the null hypotheses, or H0? Now, we can't do the p-value method because negative 3.63 is not on the Z table. It only goes up to negative 3.4. So what we got to resort to is the critical value method. So with that in mind, let's begin. So to find a critical value, we're going to be using degrees of freedom and alpha. So our alpha is equal to 0.05, as stated before, and our n is equal to 96. Now we need the n because degrees of freedom is equal to n minus 1. So we're going to plug in n for 90. We're going to plug in 96 for n. So 96 minus 1 is equal to 95. So therefore, degrees of freedom is equal to 95. And with that, we're going to put these two numbers in that little format right there. It's going to look something like this. 95 degrees of freedom alpha 0.05. Now what I want you to notice is that in our z table, there is no 95. Instead, we got an 100. So what we're going to do is we're going to round it. So we're only going to round 95 right here. So we're going to get 100, our new degrees of freedom, and alpha 0.05. And how we're going to find the critical value, as you can notice here, our alternative hypothesis has a p does not equal 0.33. So that means we're going to be dealing with a two-tail. So degrees of freedom of 100 and a two-tail of 0.05 right there. And where those two meet is 1.984. And with that, we got a critical value of 1.984. But we're not done yet. As said before, we are dealing with a non-equal sign, which means it's a two-tail. So that means our critical value is actually plus and minus, or positive and negative 1.984. And now that part's done, let's go ahead and make our figure. So I'm going to write it out in pink. Critical value is equal to positive negative 1.84. And our z value in green is equal to negative 3.63. Now I'm going to create this figure right here. I've already done some of the work, but I'll explain what to do. Obviously, we're dealing with a two-tailed, so we're occupying the negative and positive space. So with that in mind, we're going to put where we think negative 1.94 and positive 1.94 is occupying the space. So in the line, and then shade it in. Next up, we're going to figure out where z is placed in this whole figure. It's not going to be over here because it's not a positive number. And it's going to be over here because it is a negative number and it is higher than negative 1.84. So that means it is put in the shaded region. So what that means is that HO is rejected. And in the case of the homework, the answer is considered to be a yes. A yes. So that is how to do number 18. Have a good rest of the night.